How can I fix unstable PWM in power electronics projects? Imagine trying to control a light dimmer or a motor speed, but the brightness or speed keeps flickering or jumping. That's what unstable pulse width modulation can do in your power electronics projects. It can cause erratic operation, reduce efficiency, and even damage components. So how do you make that PWM signal steady and reliable? Let's break it down. First, understand that pulse width modulation controls power by switching a signal on and off rapidly. The duty cycle, or how long the switch stays on versus off, determines the average power delivered. When PWM becomes unstable, it often shows as jittering frequency, fluctuating voltage, or erratic switching. To fix this, start by improving your control circuit design. Use proper compensation networks in your feedback loops. Adjust the compensation to balance between fast response and stability. Too high bandwidth can cause oscillations, while too low can slow down your system. Keep your duty cycle within a safe range, avoiding very close to 0 or 100%, because control becomes tricky at those extremes. Next, focus on reducing noise and electromagnetic interference. Switching power supplies generate high-frequency harmonics and fast edges that can disturb your PWM signal. Use filters, shielding, and good layout techniques to cut down on electromagnetic interference. Limit the rate of voltage chain by softening switching edges with snubber circuits. These circuits absorb transients and ringing, making your PWM more stable. Keep sensitive analog circuits away from noisy switching nodes to prevent interference that can cause erratic readings or control errors. Address switching transients and load effects too. Sudden changes in voltage or inrush currents can cause oscillations. Use input filters and soft start circuits to smooth out these effects. Properly size and place inductors and capacitors to smooth current and voltage ripples. This helps your system stay steady during load changes. Also, check all hardware connections. Loose or poor solder joints, especially on breadboards or prototypes, can cause unpredictable behavior. Use proper gate drivers for transistors or MOSFETs to ensure clean, fast switching without partial conduction or oscillations. Use diagnostic tools like oscilloscopes and spectrum analyzers. They let you see the waveform, switching edges, and noise levels. Look for irregular pulse widths, ringing, or unexpected oscillations. Testing how your circuit responds to load changes helps identify stability issues. If your PWM is still unstable, revisit your control parameters, especially the compensation network. Fine-tuning these settings can make a big difference. Also, verify your hardware setup, ensuring all connections are solid and components are correctly rated. In power systems and renewable energy applications, stable PWM is key. In motor drives or choppers, it prevents torque ripple and overheating. In solar inverters or battery chargers, it ensures efficient power conversion and protects your components from voltage spikes. By carefully tuning your control loops, reducing noise, and verifying your hardware, you can fix unstable PWM signals and make your projects run smoothly. Remember, patience and precise adjustments are your best tools for success.